Dennis Reader here. I'd like to share with you a creation of mine developed over years of working in the food and beverage production facilities throughout the United States as a PLC programmer, electronic technician, fabricating different devices used on production machinery, testing, and countless other needs in a production facility that I get hired for. This particular system I'm showing here is of devices seen in many production and manufacturing plants which manage the complete handling of containers from the time that they are placed onto a conveyor, past a variety of machinery which clean, fill, cap, label, inspect, case, pack, palletize, and load onto a big rig countless varieties of containers that we find on the store shelf. Many aspects of production are managed by PLC controllers, which are found in each piece of machinery on the plant floor, and those individual PLCs are further managed by master PLCs, such as this one, to govern the flow of containers throughout a production floor. Machinery talks to each other through different devices within a PLC rack, such as this, by either DeviceNet, which is a communications protocol, and Ethernet, data highway, remote I/O, and also touchscreens, which I also do touchscreen programming. Most rotary machinery's physical position during movement is represented by binary values produced in an encoder, such as this particular device here. It displays machine positioning, like in this particular device here, the speed, and a host of other information which is then input into the PLC processor for processing. And this particular one here, I'm going to show you, if I just move this shaft ever so slightly, it shows up on this particular device here. So from 0 to 1000 is one 360-degree rotation of this particular shaft, which would represent one placement or bottle plate on a particular container. Now within that 1000 counts, this information is sent to the processor, and then any particular value from 0 to 1000 can be used to output to, let's say, a insert of a body front label or body back, neck label, shoulder label, and so on. And then it tracks the container through the machinery, also for inspection and so on. So touchscreens are used extensively in machinery, on machinery in plants, and in this particular case, here's an example of controlling this particular motor, which simulates a production machinery machine that I'm using as a miniature three-phase motor to drive this encoder. Otherwise, the encoder is driven through mechanical positioning of the machine, in this case represented by this particular shaft. So when I start this particular motor, I can go down to my panel and hit the start button, and then of course in a PLC program, that start button is shown here. If I can get this for you, kind of hard to hold this steady enough. Anyhow, here is the start. When I hit that start button, that's going to light up. It's going to come on. Where is the start button? If I hold it in long enough, it will come on. There it is. And then now it shows the green start button as being on. When I hit the stop button, this particular logic will open up and stop, of course, stop the motor. Now, what I can do here is I'll just cursor down here and come up to the particular motor run speed, which is now set at 250, I can change that, let's say, to 500. So I come up to this screen here and press the button to change speed, and maybe I'll put a value of 500, which represents 50 hertz. Input that, and now when I press the start button over here, this will go up to 50 hertz, and this of course will run much faster, and the faster speed is represented on the encoder. And this encoder value, of course, is entered into the PLC. And on here now we see 500. Hold this steady enough. So all these buttons here represent or emulate different conditions on a line, like in-feed and discharge bottle population. And these are inputs and outputs to and from the PLC. And up here is Ethernet router, so I can plug in to all different machinery, different types of Ethernet systems that I can emulate here. So, pretty interesting. Anyhow, that is a kind of story of what I've been doing for the last 35 years. Thanks for your attention, fellas.